Now, I can't explain why I think VPNs are the coolest things since sliced bread, but I've just always thought that as a network engineer, VPNs are just the coolest thing that you can do. And DMVPN is no exception to the rule. I love DMVPN. But the thing with DMVPN is there's just a lot of commands to memorize. Now, somehow in this video, I remembered them, but I may not remember them on the day that it comes to actually do the lab exam. So my encouragement to you is if you go through this practice exam, if you're following along, this is one of those videos where you probably want to repeat the task a few times so that you get the muscle memory of typing those commands down, and that way you don't get into a lab exam situation and forget one particular command that brings the whole thing to life or something like that. Also pay attention to the show commands at the very end because they're going to be very important in the lab exam, which they've identified is actually a troubleshooting portion of the exam. They give you a working DMVPN, you have to figure out why it's not. So in this video, we're going to deploy a dual hub phase 3 DMVPN and then check out how it's working with some show commands at the end. Let's get going. All right, what's up everybody? We're bringing it back again and carrying on with this CCIE practice lab thing that we're doing here. Here's the thing, now we're going to tackle DMVPN, and here's really the thing about DMVPN. If you're not doing DMVPN every day, it's really easy to forget all these commands. So there's a decent chance I may forget some of these commands along the way, especially if we start tackling crypto and IGV2. I also want to say this about DMVPN. When it comes to DMVPN, especially on the CCIE lab exam, the action verb in the blueprint is troubleshoot. It's not configure. But I feel pretty strongly that if you can configure it, you'll be able to troubleshoot it better. Beyond that, when you deploy this thing from scratch, you have the opportunity to intentionally break something along the way and see what it does, see how it behaves, and then troubleshoot that, do some show commands and see what it looks like when things go wrong. Because you know how to configure it correctly. So I'm going to intentionally forget authentication or intentionally put, the NHS server in the wrong place or something like that. So that's my intention here with this when we're going to go through this task. So let's take a look at the task first. We'll bring up DMVPN. And here we go. So customer 2, this is the green site where we had all of that MPLS layer 3 VPN fun. Customer 2 has decided to migrate off of MPLS layer 3 VPN and into DMVPN. Go figure. Step 1, delete any relevant MPLS layer 3 VPN configs on the customer 2 edges, restoring all connectivity on their LAN side. No VRFs should remain if they are present. Okay, so we're going to delete the VRFs. We'll probably have to reassign the IP addresses on those interfaces, and we'll have to reconfigure EIGRP on the LAN side because EIGRP was all in named mode and in the VRF configuration. So that's going to be step 1. Step 2, create a dual hub DMVPN over the internet links. Okay, so all sites should operate in the same EIGRP autonomous system, ASN 50, and exchange routes via DMVPN. Okay, so we may end up having to delete the LAN side or reconfigure the LAN side anyways, everywhere throughout the LAN, if we didn't use ASN 50. I think we did over on sites 1 and 2, but not on sites 3 and 4, so we'll have to look into that. Confirm that each site can reach another site's WAN link. Okay, so we need to have like a default route that sends it to the internet, and the internet should have exchanged those routes via BGP. We configured all that already in the first step. So we just need a default route towards the internet there. Site 3 and 4 over here on the right hand side are going to be our hubs. That's R11 and R13. Sites 1 and 2 should be spokes. Tunnel IP address should be 192.168.43, so we've got a subnet there. DMVPN should be phase 3, so we need redirect and shortcut. NHRP should use authentication with a password, okay, IP NHRP authentication. And then IGV2 should be leveraged to secure tunnels. So my plan of attack here, because I know I'm going to slip up on IGV2, it's IGV2 keyring, then IGV2 profile, then IPsec transform set with mode of transport. I got to remember that. And then you create the IPsec profile where you do set IPsec transform set and set IGV2 profile or something like that. There's a set command. We're going to use question mark to figure it out. So I'm going to save crypto for last. And just make sure that we can bring the DMVPN up. So let's just bring up our WAN routers in this case. This is going to be R7 and R9. In fact, here, let's do split screen. Let's get that going. I left Twitter open. I was too happy talking about stuff on Twitter. If you don't follow me on Twitter, shameless promotion here. I'm active on Twitter. We can chat. So hit me up. Data_Knox. R10 and R12. So first things first, we got to get rid of all of these VRFs. So we're getting rid of the MPLS Layer 3 VPN. All of these were configured on E00 for MPLS Layer 3 VPN. So let's do show run interface E00. Okay. Interface Ethernet E00, no VRF forwarding. Actually, config T interface Ethernet E00, no VRF forwarding WAN. IP address 192.169. Then it's going to be from there on us to figure it out. Okay. I'm just going to give myself this too. Show run interface Ethernet E00. That way I can just do this super quickly. But first, oh, I didn't like that. No, because I apparently grabbed the show command. Okay, 192.168.169.47.7 255.255.255.0. Okay. Now let's do show run pipe section EIGRP. Okay. Config T. No, I'm already in the router EIGRP CCIE. We are going to do no. Just get rid of this entire address family from the WAN side. And we really need to get rid of this entire address family for the LAN side too, don't we? Okay. And now we are going to go into address family IPv4 unicast autonomous system 50. And we're going to recreate what we had here. There we go. And let's do no router. We had BGP in here too, didn't we? Do show run interface. Not interface, section BGP. And we're going to do no router BGP 65. Okay, so if I do show IP route, what do I have? Nothing. Okay. Do show run section EIGRP. Let's make sure everything's looking kosher here. Also have to get rid of the VRF on the LAN side too. Okay, something to keep in mind. Do show run interface Ethernet 02. Interface Ethernet 02. No VRF forwarding LAN. Set the IP address back. Right there. EIGRP adjacency came up. Probably messed up my multicast section 2. You know, do I really want to mess with fixing multicast right now? I mean, there's not much to fix here. IP PIM, RP address. IP PIM, RP. I must have had debug on. Look at all that. Uh-oh. Not pin, PIM. PIM. Okay, so anyways, at this point now if I do show IP route, yep, I see all these routes. These are still external because they're being learned over MPLS on the other side. So now we need to jump over to R9 and we're going to break that connection. So enable, let's just grab this real quick. 29.9, 255, 255, 255.0, interface Ethernet 0. Ooh, R7 had a lot of stuff in the VRFs, wait, didn't they? They did, 2, 3, and 1, 0. Forgot one thing. Do show run interface Ethernet 0, 3. Yep, and Ethernet 1/0. Yeah, I remembered this one had multiple interfaces, so we need to fix each of these. Ethernet 0, 3, no VRF forwarding LAN. Set the IP address back. This is why my PIM adjacencies didn't come up. And interface Ethernet 1/0, no VRF forwarding LAN. IP address here. Okay. Now do show IP route. Looking a lot better. Okay. Great. Now we can go over here to R9. We fixed interface Ethernet 0, 0. Now we got to fix interface Ethernet 0, 2. Do show run interface Ethernet 0, 2. Interface Ethernet 0, 2. No VRF forwarding LAN. Reset the IP address. Just check the PIM one more time. I don't know if I actually fixed PIM here. Yeah, I didn't even do anything with PIM here. I didn't even set the VRF on this one. So that probably means I did the multicast section wrong on R9, but that's okay. We were undoing it anyways. So now if I do show IP route, no adjacency is up between E02 and E00. Do show run interface Ethernet 02. Oh, because we got to fix EIGRP. Do show run section EIGRP. No, router EIGRP, CCIE. No address family. This one. This one. There we go. And no. I like that you can click 3 times in Secure CRT and it copies the whole line. It would make me so happy if we could use like a Secure CRT-like tool in the CCIE exam. I mean, you know, Secure CRT runs on Linux. I have it on my Ubuntu machine. And I can even get EVE-NG to launch in Secure CRT from my Linux machine. It's so nice. Address family IPv4 unicast autonomous system 50. We're going to re-put 50 in here. So let's just copy and paste all this. Paste here. You know, I'm going to fix this redistribute statement here. No. Oh, yep, yep. Okay. No, there we go. Let's get rid of BGP entirely. No router BGP. Oop, let's exit out of this. Exit, exit, exit. No router BGP 65012. To show IP route. Awesome. Cool. Just curious, just out of curiosity, do show IP M route. Not exactly what I was hoping for, but not the end of the world either. Okay. Let's fix R10. Enable. Okay, whoop, nope. 103, 10, 255, 255, 255.0. Also remember we're changing this one to like do show run section EIGRP. Yeah, we're changing the autonomous system on this one. It doesn't even look like I'm running an autonomous system on the LAN side anyway, so it doesn't matter. Okay. I guess when I was doing all that VRF stuff, I just skipped R10. Am I even looking at the right router? No, I am on the wrong router. I should be on R11, not 10. Man, I'm about to blow some stuff up. Wow. The attention to details, y'all. I am... Whew. It's a good thing, you know, I'm going through all this stuff right now because it's like, man, if you were to roll into the exam without that, with this level of focus, just missing the obvious things, it would not be pretty. Do show run interface. This is one where I have the switches. So I've got E03 and E02. Let's look at E02 first. Interface E02. No VRF forwarding LAN. Grab the IP address again. 123. Boop. And interface Ethernet E03. No VRF forwarding LAN. Oh, did I forget to do show run? What have I done? Show IP interface brief. I think it's 244. We're gonna find out. Let's see what the switch on the inside of that had. Oop, there's some free video games there. Y'all want to play some free video games? That was E03, right? I think it's 244. Yeah, we're good. Okay, cool. Okay. All right. So let's get rid of switch 30. We don't need it anymore. We're back on R11, and we are looking at do show run section EIGRP. And we're going to delete all this stuff. Router EIGRP, CCIE. No. Address family WAN. No. Address family LAN. Address family IPv4 unicast autonomous system 50. Let's just grab the network statements here. That's the only thing I need. And we now do have to fix the switches. I closed those console sessions out, but we need to fix them both. Okay. Just set this back. Oop. Oh, what have I? Oh man, now it's really messed up. Here we go. Okay, cool. So now we've got switch 30 here. Show run section EIGRP. Cool. Nothing too bad here. No router EIGRP 60. Router EIGRP 50. Just grab that network statement. Same thing with switch 32, I bet. Show run section EIGRP. Big T. No router EIGRP 60. Router EIGRP 50. Grab that network statement. Dual adjacency is up. So I see my two adjacencies are up here. Do show IP route. Cool beans. Cool beans. And look, I already have a little static route here for my default route. I don't think I have a default route anywhere else, but maybe there. But that's okay. As long as the default route is there, we can get via the tunnel, and that is cool. All right, R12. If I kind of thumb this over a little bit so you can see. Ah, man, I did it again. Odd numbers are for customer 2, not even numbers. Okay. Let's grab my little quick start. Okay. IP add 135.13.255.255.255.0. Interface Ethernet E02. Do show run interface Ethernet E02. No VRF forwarding LAN. Grab the IP address statement. Do show run section EIGRP. Router EIGRP CCIE. No. Let's grab the address family. Delete that. No. Grab the other address family. Delete that. Address family, IPv4, unicast, autonomous system 50. And just grab the two network statements right here. Cool. I feel like a neighbor adjacency should have come up already, but it is not coming up already because it's not autonomous system 50 on this side either, is it? Let's go over to R17. We got a lot of stuff to fix. There's a few routers over here. Show run section EIGRP. Config T. Router EIGRP. CCIE. No address family. Address family IPv4 unicast autonomous system 50. Grab it all. Okay. Okay, my adjacency came up over there, but it killed my adjacencies down here. Right? Yep. Big T, router EIGRP, CCIE, no. Grab the address family. Address family, IPv4, unicast autonomous system 50. Grab my network statements. And lastly, R40. Run section EIGRP. T router EIGRP CCIE. No. Grab the address family. Paste. Address family IPv4 unicast autonomous system 50. And my network statements. All right. So now R13. If I do show IP route, we should have some EIGRP. These are the ones that we leaked out of that stub. Those were the loopbacks, and that is perfectly good to go for me. All right, so step 1 is done. Delete all relevant MPLS layer 3 VPA, no VRFs remain. I mean, the VRFs are still in the config, but they're not on the interfaces, so I'm fine with that. All right, create a dual hub DMVPN solution. All sites should operate in EIGRP ASN 50. Done. And exchange routes via DMVPN. That will be done. Confirm that each site can reach each other's WAN link. Okay, so now we need to get the default routes to go out via the WAN link. So show IP route. So the WAN, the internet links are 192.168. So if I do an IP route, this is going to be 0.0.192.168. I see my link is 7 because I'm router 7. The local octet is going to be 7. The remote octet should always be 1, but we can confirm that by looking at the ISP config real quick. Enable show IP route, or show IP interface brief. Yeah, so 7.1 and 6.1, so this is good. Okay, close that one out just to leave so there's not any confusion. So we now have an IP route on R7. Let's do show IP route on R9. Okay. Already in there. IP route 0.0.0.1.2.3.4. 192.168.9.1. 11 should be kind of the same treatment. Oh, we already have a default route here. Exit, IP route 0.0.0.123.4.192.168.13.1. Okay. Do show IP route. Okay. Do ping 192.168.7.7. Fingers crossed. Not gonna make it. Okay, why not? Why not? Why aren't you making it there? Let's take a look. So it's going to go out 13 into ISP 300. ISP 300 needs to have a route. Show IP route towards 192.168.7. It does via 3440, which means I'm pretty sure that's this guy here. Show IP route via 143.143.143, which is here. And then it's locally connected. Why did it die? Because there's no 13. Is ISP 300 not advertising R13? That's a problem. BGP, IPv4 unicast. Show BGP, IPv4. I got a feeling that we didn't advertise our local networks. That's not good, y'all. Do show run section BGP. Sure didn't. Okay. Router BGP 300. Address family IPv4 unicast. Network 192.168.13.0. Mask 255.255.255.0. Now I see 7, 9, and 11 already in the routing table, so I'm not terribly concerned there. So now when I look on show IP route, come on. IPv4 unicast. Well, well, that'll do it. I don't have an IP address there. Interface Ethernet 03. Okay, so IP address. Even the best fall down sometime. And temptation was to do copy run start there, but I didn't. I did not. No copy run start. And 13 is there now, and from our 13, come on, go the distance. Go the distance. Yes. First one lost to ARP. Can we ping 9.9? Yep. Can we ping 11.11? Round trip. So that means the internet backbone officially works. Man, how did I just manage to pick the one router where I forgot to assign an IP address? Okay. So there. Step 2 is now done for our DMVPN configuration. We haven't even done a DMVPN configuration yet. And I've lost the lab tasks. So let's just bring them back up. Okay. Let's slide things over. Make it look pretty. Yeah, that's good enough. Site 3 and 4 should be hubs. Site 3 and 4 are 11 and 13. And I want this tunnel interface to be sourced from my WAN interface. It tells us down there in step 5 what the IP address should be. So now this is the part where you have to start thinking, okay, what are my configuration steps for DMVPN again? Interface tunnel, let's say 0. That's fine with me. Tunnel source is going to be, what is my tunnel source for 192.168? E01, E01. IP address is going to be 192.168.43. Let's call this 11.255.255.255.0. Just out of habit. I say no shut every time. Tunnel mode is multi-point GRE multi-point. What else do we need to do here? IP NHRP. We're going to map multicast dynamic. We had authentication requirements, right? Authentication was going to be data Knox. We said this is going to be phase 3. So that's IP NHRP redirect. We also know that with hubs, and we're going to be running EIGRP, so we need no IP split horizon. Nope, this is named configuration mode, named CCIE. So we have to set that under the address interface configuration under the address family. Okay, just for fun, do show run interface tunnel 0. What am I missing? I'm missing a lot. Okay, so we're missing the NHRP network ID. We're missing tunnel protection, which we're going to do later. EIGRP split horizon. We don't need to do next stop self, or no next stop self, because this is phase 3. That's kind of the cool thing about phase 3. MTU, IP MTU 1400, and IP TCP adjust MSS 1360? Question mark? I think it's 1360. Okay, do show run interface tunnel 0. It didn't even take my map multicast dynamic command, I guess, because you don't need it. I guess that's the default on tunnel mode GRE multipoint. Okay, IP NHRP, let's bring it to life. Network ID is what turns it on. Network ID 1, how about that? You can also do like a tunnel key if you really want to. You know, it's fine, you can do that. I don't think we need to. And I said I was going to save crypto for last, right? I did. So let's bring up our 13 now. Okay, nope. Config T, interface tunnel 0. God, you could almost copy and paste what we just did, couldn't we? Let's take a look. Outside of the IP address, all of this stuff is gold. So let's just do that. So we're in interface tunnel 0. Yep. Paste IP address 192.168.43.13.255.255.255.0. No shut, just out of habit. Now let's bring up our spokes. That's R7. Interface tunnel 0. Interface tunnel 1. Interface tunnel 2. There we go. Interface tunnel 2, do the trick. Let's just take a look at some of the things that I had just done here that I know we're going to do. So since this is phase 3, I'm going to use multi-point. I'm not going to use redirect. I'm going to use shortcut. So let me copy some of the things down that I want. I want MTU and authentication. I want IP NHRP shortcut. I want these items here, but now I have to do IP NHRP NHS, and that's where I'm going to stop so that I can configure this on the hub. Now, okay, so here's the thing with IP NHRP NHS. If you watch like 90% of training out there, they're going to do IP NHRP NHS. Then on the next line, they're going to do IP NHRP map. Then on the next line, they're going to do IP NHRP map multicast. And you can do it all on one line. See, check this out. So if I do IP NHRP NHS and I set my first server to be 192.168.43.13, the next option is NBMA. What's the NBMA address of it? And we're going to say 192.168.13.13 and then multicast. You can do it all on one line. Do I even have the... Yeah, I can even do the priority here too. So since this is phase 3, we have to specify who's going to be our primary hub and in what cluster. So I can set priority here to 1 in cluster 1. Press enter. Now if I press up, I can rerun this command for the other hub, which is going to be 11, who's located at 11, and set the priority to... What have I done? Okay, try it again. We'll set the secondary NHS server to be 11, the NBMA address to 11, and 11, the priority here is 2. So now if I do show IP, do show run interface tunnel 0, let's look. Instead, it did something else. Do show run interface tunnel 0. Why is that show run interface tunnel 0? Oh, interface tunnel. This is like tunnel 2, right? Yeah. I don't know why I kept doing copy run start on me there. Okay, so we got no IP address, no IP redirects. Oh, we need to set an IP address. Duh. Interface tunnel 2, IP address 192.168.43.7.255.255.255.0. I've got authentication. I need the network ID, IP NHRP network ID. Let's call it 1. I think I forgot that on R13. Yeah, IP NHRP network ID 1. And I did run that here, right? Yeah. So now do show run interface tunnel 2. Okay, let's do show DMVPN. Hey, look at that. I now have 2 peers set up in the upstate. So that's awesome. Do show run interface tunnel 0. Dang it, I did it again. Okay, so let's do this. Let's grab this. I'm just going to copy. This is for the spoke config, so I'm going to paste it down here. We're going to change the addresses for router 9. I think that's the only thing I need to change here for router 9. Copy this over here to router 9. Interface config T. Interface tunnel. I'm going to set this to 1 because I know PIM is running over here. We'll change these configs. Tunnel mode is up. Do show DMVPN. There we go. 2 in the upstate. Do show IP NHRP. Look at that. So cool. So cool. Makes me so happy. What does the hub think about it? Do show DMVPN. Show it in the upstate on the hub. So now what we could do is we could bring EIGRP into the mix, then bring up IGV2 and the IPsec tunnels on it. And as we bring the IPsec tunnels out, we can see them. You know, the tunnels are going to flap because they're going to go down and then they're going to go back up or whatever. So let's do this first too. We need to set on the hubs the EIGRP no IP split horizon command. So router EIGRP CCIE address family IPv4 unicast autonomous system 50 AF interface tunnel 0 no split horizon. Same thing over here, router EIGRP CCIE address family IPv4 unicast autonomous system 50 AF interface tunnel 0 no split horizon. Now I can exit out of AF interface configuration mode and we can start advertising routes via 23255. Let's grab this. EIGRP over the tunnel. Boop. R13, exit. Boop. R9, router EIGRP CCIE address family IPv4 unicast autonomous system 50. Boop. Oh, so cool. Router EIGRP CCIE address family IPv4 unicast autonomous system 50. Boop. Bring up 3 adjacencies. Peer to 11 and 13, which are the hubs, which is what I expect. I don't expect an adjacency to come to a spoke yet until I try to reach it. So if I do show IP route, look at all that. End-to-end connectivity across the board. Oh, this makes me just so stinking happy. Like, I'm just out of curiosity now. Like, if I look at R17, I'm pretty sure we configured as a stub, right? Enable show IP route. Yeah, it's still got some good info coming in across the tunnels here. Still learning the routes across the tunnels. So theoretically, I should have no problem pinging like R9's loopback from here. Ping 9.9.9.9, source from my loopback of loopback 0. Did I just deploy DMVPN from memory? Let's just see if I can make it worse by adding crypto into the mix. Okay, so this is going to be a lot of context-sensitive help. Crypto, IGV2, key profile? No, maybe? Keyring, there it is. Crypto, we do have to do a profile, but you have to have a keyring first. So I'm going to call this IGV2 key. We got to specify a peer. We're going to give it the peer a name of any. The address of the peer is going to be 0000. Do I have to specify mask? Yep. 0000. And the pre-shared key itself, what do we want to call? What do we have to say? We can come up with our own key. I'm just going to use data Knox because that's what was specified in step 7. Okay, so now we have the keyring set up for IGV2. Let's exit out of the keyring. Crypto, IGV2, profile, and give it a name. IGV2 prof, how about that? Okay, it even tells you what to do. A local and remote authentication must be set, and a match identity must be set as well. So let's say match. We're going to say identity, right? Remote address 0000 0000. So this means we're going to set this to any remote address is allowed to connect inbound. I'm just going to set that because it didn't specify anything else. Authentication local is pre-share. Key? Oh no, we can just set it to be pre-share because we're going to specify a pre-share key. Okay, authentication remote pre-share, and then the actual pre-share key itself, right? Keyring, right there. Keyring is my local keyring of IGV2 key. Ha! Okay. Crypto, now we have to do the IPsec tunnel the phase 2 stuff, the IPsec transform set. Give it a name. I'm going to call this transforms. How about that? The first thing we're going to do, let's do SHA-256 HMAC. SHA-256 HMAC and ESP AES. We have to specify the number of keys for AES. How about 192? Press enter. Tunnel mode. Oh, mode. Transport. Okay, so that should be my transform set. The last thing is crypto IPsec profile. And we'll just call this profile for short. Oh. Well, I'm glad they bought a Dell R620. Thanks for watching. You're watching me on a Dell R710 right now. Cool. So let's do that. We're going to set the transform set to be, what do we call it? Transform. And set the IKE v2 profile to be IKE2 prof. Okay. Do show run section crypto. Darn right, I'm going to copy all that. And now the last but not least, interface tunnel 0. Right, because we're on this device. Interface tunnel 2, tunnel protection, IPsec, and then the profile name, right, which we called profile. This will break the tunnel. Nope. Sec. You have to specify the word profile followed by profile. So now let's do this. R9, exit, exit, whoop. Let's do interface tunnel 1. Tunnel protection, IPsec, profile, profile. Exit, exit, paste in, exit, interface tunnel 0. Tunnel protection, IPsec, profile, profile. Does this bring any adjacencies back up? Sure does. Exit, exit, interface. Nope, gotta paste all the crypto. Exit, interface tunnel 0. Tunnel protection, IPsec, profile, profile. Come on, bring me up to adjacencies. DMVPN is up and working. This one feels good. Do show DMVPN. So now the cool part. Show IP route. Let's bring it up. So something to like, you know, honestly, we would have learned R9 internally. We wouldn't have learned it over the tunnel. Yeah, we did. We learned it over. Oh, you know what? That's something we forgot. Setting bandwidth and delay. We're running EIGRP on these tunnel interfaces. So it's probably got these like redonkulous metrics. Like, let's see, what are we learning from like across the way? Like 17. Yeah, that's pretty high metric. Let's do show IP EIGRP topology for 17. 17/32. Do we have to specify the mask? Yeah, 255, 255, 255, 255. Yeah, bandwidth is 100 kilobit. Okay, so this is why you have to set bandwidth and delay on your tunnel interfaces. Otherwise, EIGRP is not really useful. So let's go into interface tunnel 2, bandwidth. What is it in kilobits? Kilobits. 1, 2, 3. 1, 2, 3. Let's make it gig. Delay of 2. I don't know. R9, interface tunnel 1, bandwidth 1, 2, 3. 1, 2, 3. Delay 2. R11. I think we're already in there. So how about bandwidth 1, 2, 3. 1, 2, 3. Delay 2. Lastly, big T, interface tunnel 0. Bandwidth 1, 2, 3. 1, 2, 3. Delay 2. Now, I should expect my metrics to actually look a little bit better. Yeah, metrics definitely look a little bit better, which makes me happy. That makes me really, really happy. I'm glad we did that. Okay. So, this should bring up DMVPN. If I hadn't learned about all of these routes internally, I mean, we can do something like this. Watch this. Config T, no, exit. Let's go into R9. Let's just kind of break it to see what it does. Interface Ethernet 02, shut. So now we're only going to learn routes over the DMVPN tunnel. Show IP route. Yep, so now all of these routes come over the tunnel. We can see I have 2 routes that are advertised to me. One for 13, one for 11. One for 13, one for 11, one for 13, one for 11, and so on and so on and so on, which is cool. Notice here R7's loopback is from 13 and 11. First of all, if there were multiple best paths there, so like R13 is only allowed to advertise one path to me, and R11 is only allowed basically to advertise one path to me. But if it did have equal cost paths to that interface, it could advertise both. We would have to go into topology base and use the add paths command that is specifically, I don't know if it's specifically, but it's definitely for DMVPN, so that a hub router could advertise 2 paths if they're both the equal cost path to get across the tunnel somewhere. So keep that in mind for the lab environment. Add paths is on the blueprint. So R9 can only reach R7 over the tunnel now. So if I do, hang on, let's do some fun. Trace route 7777. The trace route takes so long. I wish there was a way I can make this go faster. I can't. It's just, or maybe I can and I just don't know it and I haven't Googled it and I'm just patient enough to figure it out. So, okay, so this is the big thing. We see it goes to router 11 first, and then I should expect it to go to router 7, then up to the loopback. Oh, nope, it also went to router 13. So it went to both hubs. I guess because it saw like the opportunity to send equal cost multipaths, so multiple pings and packets are going across the tunnel. Oh, okay. Invalid SPI for destination. That's funny. Okay, but there, it does make it to router 7. Right, it's kind of jumbled, but you can see 192.168.43.7, and then it makes it there. So now, let's do show IP route, and we have the beautiful percent sign. The beautiful percent sign right here tells me that this route has been overridden by NHRP. And even though my next hops are 13 and 11, you can do show IP route NHRP, and it shows you your real next hop. Isn't that fascinating? It is an H symbol here for NHRP, and now I see that my route for 192.168.43.7 is directly connected via the tunnel, which I think is pretty neat. So any of these routes that are really like behind one of these other devices, like I don't know. I think I hit that show IP route output was too early. Like 17 is down here. Well, 17 is going to go straight to a hub, so it doesn't matter. Basically, any of the routes that would be on the other side of R7, so this would probably be like 56 right here. That would be the exact same thing. Let's also do show IP NHRP, not show IP route NHRP. Now you can also see the 7777 prefix is via 192.168.43.7. And this is the router used rib for the next hop. This is a really cool way to see what is really going on under the hood. How do you reach all of these other devices? And lastly, of course, there's show DMVPN. So now we're seeing some cool things here. I see my up statuses here, and yeah, the DT1 and the D2 here, these are important. We see that we dynamically learn them. We have a route installed for it, and we also have next hop override here. State is also important for troubleshooting. If you're seeing like NHRP or something, if it's not saying up, if it's saying NHRP, it means there's something wrong with your NHRP config. I think you can also do show DMVPN detail. Is that right? Detail? Yep, and this is where you can actually see the crypto configuration that's in place. So that's, always fun to dig into this and see some actual statistics and packets. If you have a crypto configuration and you're not sure what could be wrong, you want to check out the outbound SPI, check out the transform set, because the transform sets might not be matching either. All right, so that is DMVPN. We did it. I somehow did it from memory, kind of. I mean, I had to use context sensitive help. I didn't have to stop and Google anything. So kind of proud of that one. So there it is. There's Phase 3 dual hub DMVPN tested with next hop override. That feels good to be done with that one. All right, that's it. Thanks for stopping by, y'all. I'll see you in the next one.